Have you ever thought why bananas cost, for example, $2 per kilogram? Why coffee in Starbucks costs $5? Why Tesla car costs $37K? Maybe you can answer that's it because how the competitors set the prices, production costs, and so on. But have you ever thought how B2C products and games define their prices? Especially when the game earns on microtransactions. The mobile game becomes the only seller, so it has no competitors when it comes to selling the diamonds for this particular game. So, how do you define this optimal price? My name is Misha. This is my channel Misha about monetization, and today we are going to discuss this. This topic is quite interesting, and sometimes I think that I get even too excited about this topic because it is one of the most beautiful and simplest implications of microeconomics as science into real life. I did such things. I tested it. I did the modeling and it worked. It helped me to define the optimal price. And today I want to teach you this. And today I want to teach you this. Okay, now I'll need to work with my screen quite a lot because we will gonna jump into the mix of product management, microeconomics, and even a little of math. As you can see on my screen, I started with a very simple example. Imagine you are selling the bananas and for $4 you can sell your banana only to one monkey. But when the price of banana is $2, you can already sell it to 4 monkeys. Yes, this strange figure is just 4 monkey emojis. Okay, let's see how we can make it visualized. Now I built a very simple chart which is called demand curve. Basically, I showcased every dot which connects the price and how much monkeys are willing to pay this price. So you can see that for $4 only one monkey can get the banana. For $2 it's already 4 monkeys. 6 monkeys are ready to pay $1 and 5 monkeys are ready to pay something between 1 and 2 and 7 monkeys are ready to pay even a little less. Okay, so what can we do next? Let's discuss what in fact is our revenue when we are selling the bananas to monkeys. On this chart, it is the same chart, I just deleted the monkeys from it. So now it's unfortunately just boring math and figures. But you can see 4 beautiful rectangles. Basically, each rectangle represents the revenue which we are generating because geometrically speaking, we are multiplying price by quantity, and price by quantity here each can be represented as a line. Multiplication of lines, product of lines is a rectangle, and the square of this rectangle represents the revenue. So if we look just at the rectangles, it already can give us a hint which price is the optimal. We definitely understand that it is either blue rectangle or purple rectangle, because orange and green look a little too small compared to these two. I don't even measure it. You can just observe it visually. And actually, if you look at these pictures, you can understand that you can pick any dot on the green line on the chart, make the lines projections of this dot to the axis, like to Q axis and to P axis, and the resulting rectangle would represent the revenue which this amount of monkeys buying at this price will generate you. Like even if it is 5.5 monkeys. Now let's get to some math. For now it will be very simple, but we need to discuss it one more time. As we see, revenue is the product of price and quantity. And we actually, because we have this green line, can say that price can be represented as a function of quantity. What does it mean? For every value which quantity may have, the price will have only one defined value. So this means that price can be defined by quantity. Sometimes it is easy, sometimes it is not easy, but there should be such a function which describes what happens to the price depending on quantity, or approximation, which also can help. And now we will do a very simple and primitive approximation. That's what scientists, economists, analysts, and especially managers do a lot. We do not work with very specific formulas. Our goal is to do everything as simple as possible. So let's look at the simpler chart. Basically, it is the same chart. You can see it. There are no changes between the charts except for one simple thing. I replaced the green line with the red line. And as you can see, the red line is not a curve. It's a straight line. And for the straight line, the beauty of it lies in the fact that you just need two dots to build this line, and you just need two dots to understand what is the equation describing this line. The equation describing this line, like it may sound too abstract, but in fact it is just something like y equals 2x plus 3, or something like this. So that's our typical math formulas. Okay, and now let's jump to a bit more difficult part of it. We need to describe the existing line, the red line. Okay, price is the function of quantity, and it is a line which means that price equals some parameter A multiplied by quantity plus B. We can use the values we see on the chart. We have a dot at 1, 4 and a dot on 6, 1. So we can say that 4, we replace price with 4, equals 1, we replace quantity with 1, multiplied by A plus B. So 4 equals A plus B. And for another dot, we also replace price and quantity with their values from the chart. So we can say 1 equals 6A plus B. What we can do next? We can subtract the first equation from the second one. We could do vice versa, like it wouldn't change much. What is important? It is B here and B there. So when we subtract b from b, we get 0. That's what we wanted. We wanted to remove b from the equation. When we subtract 4 from 1, we get -3. When we subtract 1a from 6a, we get 5a. Now we have just a simple equation. -3 equals 5a, which means that a equals minus 0.6. And now we can calculate b. b here is, we already know a, so we can use this a to add it to the first equation. 4 equals minus 0.6 plus b. So now we can add 0.6 to both sides of the equation, and we will see that b equals 4.6. And finally, we can replace a and b in our original equation for price and quantity. We can say that price equals 4.6 minus 0.6 multiplied by quantity. And you can check that both of our values will satisfy this equation. We are going to revenue calculation, and it is the most difficult part. But if you already made it to it, I'm pretty sure that you will understand everything in the next part. Okay, revenue, or now we will call it, let's call it by the first letters. R equals Q, and we want not to use just price. We want to use, instead of price, we want to use 4.6 minus 0.6Q. So R equals to Q multiplied by 4.6 minus 0.6Q, which means that R equals 4.6Q minus 0.6 quantity Q squared. Yeah, it was, I don't know why I wrote it quantity here, it's just Q squared. Okay, basically we have a formula of parabolic function now, and I remind you how it looks. Because we have the negative multiplier before Q squared, we can know that the parabolic function will go down, and it means that it will have some maximum, and it means that we have some maximum of the revenue, which is very logical if you think about it. Because if you don't have maximum of revenue, there is some way to increase your revenue by selling more and more and more, and you will never stop. When we have the parabolic function, when it has the maximum, it reaches this line, like I tried to make a dotted line. It represents the value of this derivative in this specific dot. So, the value of a derivative in the point of maximum of a parabolic function is 0, because it represents the angle of this line, and it is equal to 0, it is a horizontal line, as you can see. And that's very important for us, because now, if we take the derivative of this function, 4.6q minus 0.6q squared, we will use 0 as the value of this derivative, we will know that it happens in the point where this function reaches its maximum. That's very important to understand. That's very important to keep in mind. So now we just need to take the derivative. And for function like this, it is quite simple, because it is 4.6 minus 1.2q If you need the reminder, it is for the functions with power. You just need to use to multiply the power by the multiplier next to it and reduce the power by 1. So like 4.6q becomes 4.6 and minus 0.6 q squared becomes 0.6 multiplied by 2, which is minus 1.2, and q squared becomes q. Okay, and now we simply have this equation. 0 equals 4.6 minus 1.2q, which means that q equals to 3.833. Now we can add this value to the price definition. We remember that price was 4.6 minus 0.6 of quantity. 4.6 minus 0.6 multiplied by this q equals $2.3. And finally, we can find the revenue which we will get at this price. And this revenue will be $8.81. And it makes sense. Like if you look at the chart, our optimal dot is somewhere here. Optimal dot of, below the red line. And it makes sense. Like if we sell $2.3 bananas for $2.3, we will sell it to a little less than 4 monkeys. Of course, we know that it is not about monkeys, so like maybe we are speaking not about one monkey, but we are speaking about million of monkeys. So it's not a problem to imagine that 3.833 can be realistic. Okay, we went through the most difficult part of it, like, and you can ask, okay, but what it has to do with all the A/B testing and what we actually do? Now we are going to the happy part, because you will know that now you already are ready to solve real tasks. So what does it have to do with what we do in the games or in other B2C products? Well, the users who are exposed to some variant are the queue. Or it's better to not to check how much users bought something, but what was the share of users who bought something. So you should use conversion rates, it will be better. Your prices are P. Or if you changed multiple prices in one test, you can use the average revenue per user, and it will be your P. So you will have your P and your Q, and you will have two dots. All you have to do is solve this equation. If you have more dots, you can build even more beautiful lines than my red line, but of course it will make the whole calculation more difficult. In practice, having just two dots is very helpful. And now let's repeat what we discussed here. But before we repeat, I want to ask you to hit the like button, to ring the bell. Please ask me in the comments if something wasn't clear for you. Please also subscribe to my channel. And if you want, tell your friends and your fellow product managers, product analysts, game designers. Let them know about my channel. It will help me pretty much. But if you don't do it, I still will continue doing my videos. Okay, so now let's repeat it as I promised. Basically, this is a very important how-to. You are finding two dots on your chart. You build the function. You define a revenue as a function of only one variable. In my case, I defined it as a function of Q. But you can actually define it as a function of P. The approach will be pretty much the same. You find the maximum of a derivative of this revenue function and profit. Yes, actually, because we are speaking about products which don't have costs, we are speaking about profit. That's it for today. I was very happy to present this topic to you. I believe that it is one of the most essential parts of what product managers and product analysts can do when they work with the pricing. We are quite happy people because we can actually know how the pricing works. Like the models which economists built and they relied on science, we are the ones who can actually confirm it with practice or reject it or specify it. That's just amazing. I told you, I'm getting too excited when I'm talking about this topic. Okay, guys, I was super happy to see you today and have a very nice and beautiful weekend and the rest of your 2025. But if you watch this video not in 2025, still have something nice. Bye bye.